Can you hear me? Oh, I guess you can. All right. Hi, I'm Rudi Chiarito. I work on infrastructure at Clarifai. Welcome. So today's talk is going to be covering two main areas. First of all, we're going to be talking about scheduling, and the second smaller part is going to be about how to become or be a contributor by accident. So who am I, and how involved have I been with open source? So I've been involved with open source for about 16 years now, mostly minor contributions. For example, when I was at Amiga, we had a developer system that ran a Linux distribution. I had to maintain that. Then at Mayo Clinic, I did more work, more related work. We had one project that was brand new code. Actually, most of what I wrote you cannot see because it was about binary file formats that I reverse engineered, so we can open source that. Then I went to Google, worked in SRE, and I disappeared from the planet as far as open source is concerned. And then last year I joined Clarifai, and I've been working a lot with Kubernetes. Let's see. I should give you some background about Clarifai because pretty much the work that has been done so far for GPU resources has been influenced by our needs because we were the first to push for this. So we are a startup based in New York. Was funded by our CEO after he finished his PhD and won the ImageNet contest in 2013. We have an API offering machine learning as a service. You give us images and videos, we give you tags. We use pre-built models, custom models that you can build yourself, and then we also allow image search. We have a number of investors. I mentioned them because Nvidia is going to be mentioned throughout the talk, and I want to have the disclaimer that they're one of our investors, but it's just a coincidence. Let's see. Let's talk about workloads. Who in the crowd here is using GPUs? Okay, fair amount. How many on Kubernetes? Wow, cool. So I like to classify workloads in two broad categories. First, batch, and this is probably the vast majority of workloads. Stuff like render farms. Let's say you're rendering the next Pixar movie. This is going to be running for hours, days, weeks, whatever, or you're training machine learning models. And then there are more real-time workloads where you have stuff like machine learning predictions. We'll talk a little bit more about that. More specifically for Clarifai, we train neural networks first. This is a very intensive process. We have millions and millions of images, and then after hours, days, we get a much smaller model out of this whole process. It's a bunch of parameters that can recognize images, basically. Then out of that, we feed that into the next kind of workload, which is making predictions. So we feed the model with a much smaller set of images. Usually, it's often just one image, and this is a very quick operation. We also tend to have very variable traffic patterns. Usually, they follow the daily patterns of real users out there. They're tagging the pictures, things like that. This runs on Kubernetes on AWS. The first kind of workloads we don't run on Kubernetes yet. When I joined Clarifai, we had an old infrastructure that was starting to show its age. It was running on virtual machines. It was created when the company had maybe just 3 or 4 employees. It was very awkward. Even if you had to add a new model, you had to rebuild a whole new set of virtual machines, transfer traffic over, and then kill the old ones. So even a tiny change, one line, after committing to GitHub, it would take maybe 3 hours to deploy. And that's where I came in. So I was tasked to come up with some new infrastructure, and I had this great checklist: Kubernetes, containers, discovery, no more VMs. So sounds great, right? Well, that sounds good on paper. The problem is that in practice, Kubernetes didn't have all the features that we really needed. For example, around this time last year, there was no GPU support. If you used ELBs, you couldn't easily do SSL encryption. There was no support for ECR, and there were a bunch of bugs. You could easily get your masters or your nodes to make too many calls to AWS, and your whole account will get throttled. So we would see, I would run stuff on our test cluster, and the whole production environment would get throttled. That wasn't fun, and it wasn't even easy to debug. So how did we tackle GPU support? As I said, I was at Kubernetes KubeCon last year. I approached Eric Thune and David Oppenheimer, and I asked them about, how about we support GPUs? And magic happened. Well, not really. It took a few months, many discussions and ideas, and it turns out that you cannot just extend the Kubernetes API with the new objects and interfaces, and then later risking to undo that. So I had several proposals, but initially we just settled on something that we call Be0, which was very stripped down, very basic. This has been available since 1.3 in July. So, as I said, this has been stripped down to the bare minimum, so it has many limitations. For example, you can only use Nvidia cards. There's only support for one device per machine. It doesn't get auto-detected. You cannot tell if you have, the brand new latest Nvidia card or something from 4 years ago. You can't even find out easily how much GPU RAM you're using, or if you're using something like the Kubernetes dashboard or Datadog, you can't even say, hey, I'm using maybe 80% of my GPU devices. And last but not least, the resource name is kind of awkward. It's that fully qualified name there. But wait, there are even more limitations. Because we're dealing with Nvidia drivers, you have to be very careful with the versioning of the kernel drivers and the libraries that go with them. Also, there is a problem if you build, for example, a version of, if you build your software against a version of CUDA, you need to have a matching driver that supports that, at least that version. And the real problem there, it's not just you have this limitation, it's that if you mess up, it's going to be very difficult to even find out, because you're going to get a very unhelpful error message. And there's no check in the kubelet that even rejects even refuses to start the container. So I told you all of these limitations, but you still want to do it. So how do you do it? You basically have 3 separate steps necessary. First of all, you need to run the kubelet with a special magic flag. Second, you need to expose the libraries, and if you use Nvidia SMI, which is a diagnostic binary, you need to expose that into your pod. You don't want to package that into your images, because, as I said, the low-level libraries need to match the kernel driver. So putting the libraries in the image is a big no-no. And then last but not least, you have to request the resource. So this is what it looks like in a YAML file. I split them over 2 columns, but basically on the left side here, we are requesting the GPU, and here we are exposing the libraries and binaries. So why would you do this? It's a lot of work. As I said, you need to expose libraries. There's a lot of node setup that is necessary. For us, even with all this work, it's still a big plus, because we went from 3 hours to maybe minutes to deploy a simple code change. And if I just need to add a new model, I just click on the dashboard and I have a new replica up in a few seconds. So this was worth it. Still, we know there is a lot to do. There is a PR from Rudi, who works at HP, which is going to discover devices for you. So you don't need to pass the magic flag anymore. You can now support more than 1 GPU per machine. Not only that, if you have a container that needs more than 1 GPU, you can request that as well. There is a GPU plugin abstraction, but it's still using the Nvidia GPU resource, so we know there's still a lot to do after this. As an alternative, so the PR from Rudi just scans entries in the dev directory, and it finds the the devices. So it notices, for example, there are 2 devices, so it knows there are 2 NVIDIA cards, hopefully. There is an alternative, which is the Nvidia NVML library, which not only tells you how many devices are on the machine, you can also find out all sorts of details like vintage, memory, core count, even affinity. For example, there might be 4 cards on the system, but 2 of them are faster when talking to each other compared to the other 2, and so on. The problem with NVML is that it's native code, so you need to use CGO, and I don't believe there's any Kubernetes binary that uses CGO yet. So stability and other concerns could get in the way of merging NVML support. What else do we need? We definitely need to, as I said, expose more details about the hardware. In our case, for example, we have we call it the general model. It's the largest model that is trained to detect tens of thousands of concepts of tags, and that requires the largest hardware that we have. But then we have many smaller, almost one-off models for customers for specialized uses, and those don't need a very beefy card or machine. So being able to tell one device from the other would be helpful to reduce waste. Then also exposing affinity would be ideal. And last but not least, we would need some kind of rescheduler. This is something that has been known to the Kubernetes project for a while. There's an issue that has been open for maybe a year or 2. Basically, for example, let's say you have 4 machines with 2 cards each, and all of them have 1 card in use. Now someone comes in and they request 2 cards, and they cannot do anything because there is capacity left, but it's all stranded across multiple machines. So a rescheduler would come in and evict 1 random pod, free up 2 cards, and then let the new pod schedule on that machine. This is not really GPU specific. You can get into that kind of scenario with even just with CPU and RAM if you're very unlucky. What else is needed? I showed you earlier the YAML for setting up the pod, and that's very ugly. It's a lot of work. You can make easily mistakes, and you cannot easily share this with others. You would have to agree, for example, in which host site directory your libraries are. We have our own setup because we use CoreOS. So we have some directories where it makes sense for the libraries to be, but someone else using a different system would probably prefer another directory. So we wouldn't be able to share YAML files with our setup. Also, there is no, as I said, when the low-level libraries don't support the CUDA version that your image is built for, there is no helpful message. The container will just get started over and over and fail every time. There is something that, there is a project that Nvidia has created. It's called Nvidia Docker. It's a volume plugin. The idea is that basically you start a daemon in advance, and then the Docker daemon will talk to it when it needs to create a new container, and it will get information about, it will be given a directory where all your libraries are. So for example, let's say you need CUDA 7.5. By adding a label to your Docker image, the Nvidia Docker volume plugin knows if those libraries, if that version of CUDA is supported. If it's supported, the directory will be exposed. If it's not, it will return with an error, so the container won't even start. I have a PR to support Docker volume plugins, and the Nvidia Docker one would be one of them. The problem is that, as I said, you need a new daemon on the node. It requires a new API object, and it's tied to Docker, which brings a new can of worms into the picture. So there's no consensus yet on whether that's the way to go. Also, resource monitoring, as I said earlier, is an issue. We need to make sure that you don't have to go to the shell and run command line scripts like we do to show resources allocated on the nodes. And also having more details on what's happening inside the container. Once I have given a pod a whole GPU, I would like to know how much of the RAM is being used. And also multiple vendor support. This is all Nvidia specific because for machine learning purposes, the de facto standard is Nvidia, but we want to be able to support multiple vendors. And then this is a feature that might not apply to everyone. If you have more than one pod that doesn't use the GPU the whole time, you will be wasting resources. If you have a model, for example, that is used 10, 20% of the time, 80% of the time, you're just buying a very expensive GPU and doing nothing with it. So right now, you can actually share one GPU device between among several pods. They will just compete for each other for access, and when one of them is done, the other one will continue and do its own work. This is currently supporting Kubernetes with a weird trick, but it's definitely going to break when the new discovery code lands. So we need to find a better solution. Also, sharing a device means that you will have to ask for example, 1 gigabyte of GPU RAM out of 4 or 6, whatever is on the card. This is mostly, I don't want to say accounting fiction, but it's just something that you need to plan in advance for because there's no actual enforcement. If I ask for 1 gigabyte of GPU RAM, there's no way for the runtime to enforce that. So if I go above the request, I will cause trouble to the other pods. So this is something that you probably want to restrict to a namespace where all the pods in a namespace trust each other. You don't want to go across namespaces for this kind of use case. But as I said, this is very helpful because you don't need as many GPUs as you would normally do. So what can you do? There is a lot to be done here. We're just at the beginning. Even if you have a use case and you cannot contribute code, that's very helpful. Many times I've been in discussions where I brought up something that needed to be done, but I was the only person talking about it. So your voice will help make the case for more work in this area, and also for prioritizing the work. If you can make code changes, even better. Now, how to become an incidental contributor? You remember the features I mentioned earlier that were missing? These are not all the features that we needed, but these are the ones that were the most urgent. So they're not missing anymore. How did that happen? So nobody was working on those. I opened a bunch and nobody really was working on them. So I said, let's do it. I started with something very small, a bug in the way we did traffic shaping. And also we needed ECR support. Nobody was working on it. I ended up doing it. How do you do it? My first most important advice is to start with something very simple. You find a bug. Usually they're very restricted in the amount of work that they need and what they involve. And then this way you get familiar with the whole process, the code review, how to build and test Kubernetes, and how to rebase. More about that later. Then once you've fixed a bug or two, you can start maybe exploring how to add features. You don't have to implement something crazy, just maybe a kubelet kube control flag. That's something that will give you more experience with the code base. And then maybe from the area wherever you started, you can move into other areas of the project. But my advice there is not to overdo it. Kubernetes is a very large and complex project. If you want to learn about, I don't know if there's any one person that knows all the parts of the project very well. I would advise to maybe focus on 3, 4, 5 areas where you want to contribute the most. Be patient. As I said earlier, rebasing has been the bane of my existence, especially when you make changes to the API. But some of this is going to go away in 1.6. We won't be checking in auto-generated code. So many of the conflicts that happen now will be gone. You don't have to worry about rebasing your auto-generated code. Also, when you're in your code reviews, it's very helpful to take a step back and understand what your reviewer is commenting about, because sometimes there's a lot of context that the reviewer doesn't give you, but if you think about it, maybe you can see between the lines what they're trying to get at, and maybe some objections that they have a reason. It's just not very clear in the way they comment. I like to sometimes pick on one or two reviewers, but that's just a joke. I'm not serious about it. I understand that they're very overloaded with work, so we want to make sure that we don't waste their time. And feel free to ask questions if you have, rather than going down a rabbit hole, maybe ask one good question before you try to change your PR in a way that you will later have to undo. Add or improve tests. I don't know one person that likes writing tests, but we've been bitten by a few cases where the tests were missing or incomplete. So please write more tests. And also documentation. I believe I had one or two features where I wanted to, where I was about to file, or I even filed one, and then, filing a request, and then I found out that the feature not only existed, it was documented, but in a very remote place in the documentation. So better documentation helps a lot, and it prevents this from happening to others. And that's it. Thanks for coming. If you have questions, I'd be happy to answer them. Microphone?
Curious about the trick.
Oh, can you repeat for?
Yeah, the trick that you did for the over-committing.
Yeah, let me show you I'll show you where it happens. This flag. So you can tell that flag, there's no check, there's no validation check. Somebody brought it up and one of the viewers said, no, let's not complicate this because it's gonna be removed eventually. And I also didn't want to put the check because I had this trick already in mind. You can say, for example, I have 100 GPUs, and then you request 20. That way you get 20% of one GPU. Even if you have 20, you just get one device mapped into your container. So that way you can carve however you want that single GPU.
So is there anyone else doing this? Yeah, I mean, you guys were at...
Yes, I've seen a few hands. I guess they're using, are you all using the same resource, or are you doing your own?
We applied the patch that updated your patch.
Okay, Ouija? Okay.
It works.
Okay. What kind of workloads do you use? Do you run?
We're testing right now, so we have 4 GPUs. We try to do simple like GPU isolations of 1 pocket, 2, we gotta get 2 in about 100 parameters. The model is ended up, the Lily models was about 2 gig per model on the neural net. It's still prototype, we haven't been able to productionize, but at least it's working, so we're gonna put a comment in workplace to allow that.
Yeah. Question?
Do you have plans to move your batch workloads to Kubernetes as well? Like your
Yes. So our colo machines are run by a separate team, the data team and the research team. They don't like having to run their own machines. And they run some stuff on Kubernetes as well. So they like how flexible it is and how much time it saves them. So we want to move everything to Kubernetes as well. But as I said, there are features that are missing, and until we have those, we cannot do the migration yet. Yeah. We also have to rewrite a lot of the software because it's a very elaborate setup that we use there. Yeah. But that's the long-term plan. Yes.
So I'm wondering, what is your thought about the memory reuse on GPU? I remember one of the slides that the improvement that we could make is you're thinking about capping memory, shared global memory for a GPU, or are you thinking about?
The question is about sharing GPU RAM between multiple pods.
Are you thinking about that, or?
Yeah, this is what we do right now, as I said, with this trick, basically. So we have some models that are very large, and they can take most of the memory, and then we can give the rest to tiny models that just use a few tens of megabytes. And that works because we know in advance, we do some kind of profiling. We know how much memory each of them uses. So we know roughly, but it's not automated, it should be. And also the other thing is that our workloads are fairly static in terms of memory allocation. They allocate all the memory at the beginning. They don't allocate anything else afterwards. So we can do that. But as I said, you cannot enforce that. There's no MMU on the GPU, basically. Otherwise, yeah, it would be great. Any more questions? No? I guess we're good. Thank you for coming.